Hello everyone, this is the continuation of our lecture about the experimental research strategy. And in this topic, we are going to talk about between subjects design. Okay, because there are different ways to conduct an experiment, and this time we're going to talk about between subjects design and what you have to know about it. First, like what we did in the previous discussion, let me give you a sample study. And so, research suggests that it is more effective for students to study text on printed hard copy than to study text displayed on a computer screen. That's why when I was a student, I preferred having a physical copy of the book or printing out the PDFs that I have because I believe in this finding. When I was preparing for my licensure examination for psychometrician, I made sure that I have physical copies of the books that I'm using. If I use a soft copy version of that book, I easily get distracted by the different apps that can be seen in the computer or in the tablet. Now, in order for them to prove this, college students were randomly assigned to one of the two media conditions to study the text of 1,000 to 1,200 words, and then they were given a multiple choice test on the material. So basically, like what you learned in the previous topic, we have a manipulation and we have two treatment conditions, the hard copy version and the soft copy version. And then they were able to prove that those who have read the hard copy version scored higher in the multiple choice test compared to the one who read the soft copy version. They were able to show that one condition is definitely better than the other condition. If you would like to read more about this research, then look at the citation displayed on this slide. An experiment always involves comparison of different groups of scores. The choice between one group and multiple groups of participants is one of the characteristics that differentiate one type of experiment from another. This time, we are going to talk about multiple groups of participants rather than using a single group again and again. That's why the title of this lecture is Between Groups Design. So what is a characteristic of a between groups or a between subjects design? That's another term for it, between groups design or between samples design. It depends on the type of word that you want to use. So it compares different groups of individuals, group A versus group B versus group C. Hence, you are comparing different groups of people. A person in the group A cannot be in the group B. And the general goal of a between subjects experiment is to determine whether differences exist between two or more treatment conditions. And experimentation has been very helpful in various subfields under psychology. For example, did you know that nowadays cognitive behavioral therapy is the most scientifically supported approach in psychotherapy and counseling? It's because a number of studies in psychotherapy and counseling was able to prove that undergoing cognitive behavioral therapy is more likely to result in optimal outcomes compared to other types of therapies. So, in order for them to do that, they should compare the well being of people who have been through CBT to those who have never been through therapy and to those who undergo a different therapeutic approach in order for them to prove that CBT is a better approach. One characteristic of having a between subjects design is that it allows only one score per each participant. Hence, if you have participated already, you cannot participate again. Every individual score represents a separate, unique participant. So one score is to one person. If a between subject experiment produces 30 scores in treatment A and 30 scores in treatment B, then he should have a total of 60 participants. That perhaps is one of the downside of a between subjects design. You need to be good in recruiting participants because if you have 30 in one group, you should also have 30 in the other group in order for you to be fair. Now, here's a review of your basic statistics. So when you recruit participants, you target a certain population, but since we cannot get everyone from the population, you just get a sample, and the big circle here on the top is the sample, and then you split your sample into different groups, group 1, group 2, and group 3. So what I'm saying here is that between subjects can be between two groups, three groups, four groups, as many groups as you want. But if you have more groups, then you have to exert more effort in finding in finding participants. So, why do we have three groups here in this sample? It's because group 1 will be exposed to treatment 1. For example, that's chocolate ice cream. Group 2 is the treatment 2, that would be mango ice cream. And group 3 is the treatment condition 3, which can be vanilla ice cream. So they are separate groups. If you have tasted the chocolate ice cream already, you cannot be exposed to the vanilla ice cream manipulation. So here are advantages and the disadvantages of a between subjects design. Because each participant is measured only once, the researcher can be reasonably confident that the resulting measurement is relatively clean and uncontaminated by other treatment factors. That's why between subjects design is also known as independent measures experimental design, because group A has nothing to do with group B. And what do we mean by uncontaminated and clean? Look at this example. For example, I'm going to make you drink coffee A, then I'm going to measure your alertness, and then after 10 minutes, I'm going to make you drink coffee B, and I'm going to measure your alertness again. Obviously, you will have a higher amount of alertness after drinking coffee B. But does it mean that coffee B is better than coffee A? Not necessarily, because in that situation, drinking one cup of coffee after another can be an extraneous variable. Hence, it's not really the coffee that increases your alertness, but it's the time interval between the two cups of coffee that increase your alertness in that way. So in order for you to address that shortcoming, instead of making use of one participant to drink 2 cups of coffee within 20 minutes, then why don't you just choose two different, make person A drink coffee A and make person B drink coffee B? Isn't that better? So that your measurement is uncontaminated by different extraneous variables. The disadvantage is that they require a relatively large number of participants. So if you need 30 participants in one group, then that means that you also need another 30 for the second group. But what if you are required to do a 3-group experiment? Then you are required to get 90 participants. And it's very hard to do that, especially if your experiment is 1 hour long. So, a researcher studying preschool children with a specific learning disability might have trouble finding a large number of individuals to participate because, as you know it's very hard to find people with learning disability. And when you find them, it's not easy to recruit them because we're speaking about children here. You need to ask the permission of their parents and their teachers as well. And that takes a lot of time and effort. So that's one of the downsides of using a between subjects design. Another downside of between subjects design is the individual differences. And I will give you some time to look at the profiles of two individuals here. So John is a 21-year-old male. He's 5'10", weighs 180 pounds, has blue eyes, blonde hair, and IQ of 110. He comes from a middle-class family with one older sister. John is a chemistry major and was awake until 2 a.m. this morning after celebrating success on a chemistry exam. He comes to the experiment with only 4 hours of sleep, suffering a mild hangover. On the other hand, Mary is a 20-year-old black female, 5'3", has brown eyes, black hair, and an IQ of 142. Her mother and father are both doctors and she is an only child. Mary is a history major with a minor in psychology. She had a head cold yesterday and went to bed at 8 p.m. She arrived at the experiment well rested and feeling much better. However, she skipped breakfast and is hungry. Now, even though even if you assign John and Mary to different groups, their personal experiences will be extraneous variables in that aspects and that in this experiment, and that's what we call individual difference. Regardless how careful you are in grouping your participants, there will always be things that are outside your control. Sometimes we cannot do anything about it anymore, especially if the source of error is the individual differences or the personal experiences of the people participating in our experiment. Individual differences can become confounding variables. Suppose that a researcher finds that participants in treatment A have higher scores in treatment B the researchers would like to conclude that higher scores were caused by the treatment. For example, remember in the previous slide that Mary has an IQ of 142 and John has an IQ of 110. We made Mary drink coffee B and we made John drink coffee A. And then after that, we measured their capability to be attentive and to memorize. And then we concluded that coffee B is better because Mary scored higher. However, that's not really the case because in the first place, Mary's IQ is higher than John's IQ. Perhaps it's not the coffee, but rather it's their IQ. It's their individual differences. That's why you need to have a lot of participants so that the different errors can cancel each other out. Okay, you will know more about this as we go along. Now, here's another example of the influence of individual differences. So in treatment 1, there's a group of relatively older participants, and in treatment 2, this is a group of relatively younger participants. If the scores in one group are different from the scores in the other group, the difference may be caused by the treatments or it may be caused by the age difference. So in this experiment, we're not really interested with age. It just so happened that the participants in group 1 are older than those in group 2. And our experiment is about ability to learn a new application in the cell phone. Then perhaps those who are younger are better when it comes to learning applications in the phone compared to older participants because those who are younger are going to school, hence they are exposed to a lot of gadgets. Now we're going to conclude that those in treatment 2 are better than those in treatment 1, but in reality, it's not our manipulation, but it's their age that determined their skill. It's their age that influenced their skill when it comes to learning a new application. So you want your groups to be balanced and not to be imbalanced in this way. And that's just for age. And there are different ways to make the groups imbalance. Now, you should exert effort in trying to make your groups equivalent. And when we say that the groups are equivalent, here are some examples. If you remember last time we talked about matching, we talked about holding a variable constant. Try to recall those as we discuss these things now. So number 1, make sure that your groups are created equally. So the process used to obtain participants should be as similar as possible for all the groups. So if you recruit your participants by calling them through phone or emailing them, then try to use the same method in recruiting other participants because the difference in the way that you recruit them may also influence. What if in group A you recruited strangers but in group B you recruited some friends? Then that may cause some bias. Number 2, the groups must be treated equally. Except for treatments that are deliberately varied between groups, the group of participants should receive exactly the same experiences. So the only way that they should differ is with the manipulation and not in any other way. For example, it's ideal if the size of the room is the same between group A and group B. And number 3, composed of equivalent individuals. So the characteristics of participants in any one group should be as similar as possible to the characteristics in every other group. So we don't want to have an imbalanced group. One group has higher IQs compared to other groups, then that would be bias. Now, how do we limit confounding by individual differences? The first strategy is randomization. Recall that random assignment simply means that a random process, for example, a coin toss, is used to assign participants to groups. However, like I told you in the past lecture, we can have more heads than tails, and if that happens, then we can have more participants in group A than in group B, then our groups will be unequal when it comes to sample size. What you can do to address that is to make use of restricted random assignment. And what do we mean by that is this. To divide 90 participants into 3 equal groups, for example, the researcher could start with 90 slips of paper, 30 with number 1, 30 with number 2, and 30 with number 3, so that the groupings will be equal. So that somehow solves our problem with the coin toss. Other than that, we can also do matching, but remember our last discussion, matching may be rigorous. It may take some time and effort. For example, in a learning experiment, it is reasonable to expect that intelligence is a variable that can influence learning performance. So a researcher comparing two different methods for teaching fifth grade mathematics wants to be sure that the two groups of participants are roughly equivalent in terms of IQ. We don't want to put all top students in one group because they will outperform group B even without the manipulation. So what should this researcher do? He can look at the records in the school in order to balance the group. Or he can also set a session wherein he will measure the IQs of this individual and try to match the participants. However, that would be costly and that would take a lot of time. So here are some steps to follow in matching. The first one is identify the variable or variables to be matched. And in that case, that would be IQ. Or in your case, that can be age or gender. If you have 5 boys in group A, there should also be 5 boys in group B. Measurement of the matching variable for each participant. Of course, you no longer have to measure gender because that's obvious, but with IQ, you have to measure it. And you may have to look at the school records or to measure their IQ ahead of time. You need to quantify this variable in order for you to match them. Sometimes it's easy to quantify, sometimes it's not. For example, it's easy to match with age because if there is a 38-year-old in group A, then it's easy to find another 38-year-old for group B. But it's hard to find someone who also has 130 IQ to match someone with 130 IQ in group B. I think that's a lot difficult compared to matching with age. And number three, assign the participants to group by means of a restricted random assignment that ensures balance between the groups. So the three steps are identify the variable, measure this variable, and then assign them to groups in a way that matches them to each other. Also, we can hold the variables constant. If a researcher suspects that gender differences between groups might confound a research study, one solution is to eliminate gender as a variable. For example, why don't you just recruit all boys or all girls in your experiment? Or maybe you can do something like this: no left-handed or no right-handed individual. Other than that, here's another example. A researcher concerned about potential IQ differences between groups could restrict participants to those with IQs between 100 and 110. Sometimes outliers or those with very high or very low IQ may influence the result of our experiment. So what he did is this. He measured their IQs first and he only recruited those with IQs between 100 to 110 to make sure that there are no outliers in the group. Another way that individual differences can influence our findings is by influencing the variance or the variability of scores. And let's recall your basic statistics. When we say variance, that's the differences in scores or that's the spread in scores. Meaning, if there's a high variance, then the scores is well spread. But if there's a very low variance, then the scores are very close to each other. Okay, and to make you understand what I mean by that, let's look at two scenarios here. So in this study, what he did was compared control condition with the treatment condition, and let's just say that he's comparing the effectivity of supplemental classes given to sixth graders, and while the control group, they did not receive any type of supplemental classes. Now, it's clear that if you undergo supplemental classes, then your scores in an exam is better compared to those with no supplemental classes. And in this case, then there's no problem with the variance or the spread of scores. However, what if your situation is like this? Look at this. For example, we did the same experiment in another school. What happened here is that because of individual differences, the variance of score or the scores are so well spread to the point that we can no longer see an obvious difference. Remember that the control condition was not exposed to a supplemental class, while the treatment condition were the ones who undergo supplemental classes. So look at this. On the right side, you can see someone here scored a 60 even without supplemental classes. On the other hand, there's someone here that even with the supplemental classes, his score was very low. His score was only 30. Perhaps their individual differences or their IQ, even before the treatment, may influence the result of the study. So it's not just the manipulation influencing the results of the study, it's also their personality, it's also their ability, it's their personal characteristics. Compared to the one that I showed before, in the second situation, the differences are not so obvious. Okay, and now we're going to talk about the two types of variance. And I will illustrate that using the ASEAN countries. There are two types of variance: variance between and variance within. What's the difference? In layman's term, when we say variance between, that's the differences between the groups, or the difference between group A, group B, and group C. While when we say variance within, that's the differences inside the group. So what do we mean by that? When we compare one country versus another country in the ASEAN region, then that's variance between, because we're comparing groups with each other. However, in the Philippines, although we are considered as one group, are we different? Are we different compared to each other, compared to other Filipinos? Yes, and that's variance within. Okay? In statistics, what we want to achieve is to have a high variance between, and to have a low variance within. Okay, why? If there's too much variance in one group, that will cause a lot of error. That will be an extraneous variable in your study. Here's another example. There are three groups. They drank different types of coffee. For example, group 1 will be exposed to iced coffee, group 2 will be exposed to decaf, while group 3 will be exposed to 3 in 1. And if their scores are different in comparison to each other, that's variance between. However, in group 1, all of them drank iced coffee, but remember, even without coffee, some people are more alert compared to others. And that's variance inside the group, or another word for inside is within. So the differences among the members of group 1 is what we call variance within, and that is an extraneous variable. Let me restate it again. In statistics and in research, we want to have a high variance between, but low variance within. In other words, we want the differences to be coming from the groupings and not from the individual differences, because individual differences is an extraneous variable in research. Here are other threats to validity. For example, we also have what we call participant mortality. For example, a researcher may want to test the effectiveness of a dieting program, and he used a between subjects design. However, this dieting program will take 10 weeks. Do you think your participants can commit for 10 weeks? I don't think so. If more participants drop out from one group than the other, then there's a risk that the groups will no longer be similar. So in order to address mortality, sometimes what we do is to make our experiments short. Okay, that's one way to do it. However, mortality will always be there, so try to get the commitment of your participants. That's why sometimes we have a token or a reward for those who will finish the experiment. Other than that, one more threat to validity is the communication between groups. In example, a researcher wants to test the effectiveness of a new treatment for depression. So one participant was exposed to therapy while the other participant was not exposed to therapy. If participants talk to each other from one group to another, they share their experiences, then the individuals receiving the old treatment or those who are receiving no treatment may learn about the treatments being given to the treatment condition. And they may begin to use some elements from the new treatment. For example, I was assigned to the group that will not receive any kind of treatment, but I have a friend from the treatment condition. Then I will hear some of the techniques that he has been learning from the treatment condition, then that might influence my performance. Hence, that is another extraneous variable in research. So we don't want our participants to communicate with each other. That's why it's best to separate them as much as possible. There's also what we call diffusion, or the spread of the treatment from the experimental group to the control group, which tends to reduce the differences between two groups. So we don't want our participants to share about our experiment, especially to other participants, because that influences their performance or their answers to any scale that we will administer. Here's another example. In a study examining the effects of violent television, the boys in the non-violent television group learned that those in the violent television group were allowed to watch the television series Batman, and they demanded the right to watch it too. Okay, so they were envious of the other group, and that's one way to show you that as much as possible, separate the group so that they will not learn that there are differences between the groups, because they might be envious about the treatments that the other group is receiving. And finally, problems can occur when participants in an untreated group change their normal behavior when they learn about the special treatment that is given to another group. That's why we have what we call compensatory rivalry and resentful demoralization. When we say compensatory rivalry, one possibility is that the untreated group works extra hard to show that they can perform just as well as the individuals receiving the special treatment. So even without therapy, I will do my best to make it look like I'm getting well. So that's compensatory rivalry. Other than that, we also have what we call resentful demoralization, or the possibility that participants in an untreated group simply give up when they learn that another group is receiving special treatment. So we don't want this to happen. So as much as possible, try to get the commitment of your participants and make them promise that they're not going to share about the experiment outside the laboratory. That's one way to protect the validity of your study. Here's the application of between subjects design. Sometimes you can do a between subjects design with just two groups. That's the simplest version of the between subject design. However, you can also do between subjects design when you're dealing with multiple groups, because there are research questions that require more than two groups to evaluate functional relation between an independent variable and a dependent variable. So now, statistically speaking, when we are comparing two groups, again, we're going to use t-test, but when we are comparing three or more groups, we can use ANOVA. And that's how we relate statistics with experimental psychology. So basically, that is it for this discussion, and I hope you learned a lot about the between subjects design. And next time, let's talk about the within subjects design. That's it, and thank you.